Hey kiddos, here's the review for Spiral 10. We're going to start off with quadratic formula and dealing with complex numbers. First off, we've got to use the discriminant to figure out what's going on with our zeros. So we know that that's going to be b squared minus 4ac, which in this case it's going to be negative 6 squared minus 4 times 2 times 1. 36 minus 8 is going to be 28. And since that's greater than 0, the discriminant tells us that there should be 2 zeros associated with that. Okay, now let's do the quadratic formula for this. So x equals negative b. That's b equals negative 6. So negative 6 over 2 times a equals 2, plus or minus the square root. We already did b squared minus 4ac, we got 28, so I'm going to plug that in here. And that's going to be dividing by 2a again, so 2 times 2. So that'd be 6 over 4 plus or minus the square root of 28 over 4. Totally fine for an answer. If you'd like to get a bit of a bonus point, you could reduce this to 3 over 2. And square root of 28 could be rewritten as the square root of 4 times the square root of 7, which is 2 root 7. And since the 2 and the 4 can be divided, we end up with the square root of 7 over 2 on the other one. That'll get you a bonus point if you do that in your spiral, but it's certainly not necessary. For number 3, we're doing the same thing. We've got a equals 2, b equals negative 5, and c equals 4. And b squared minus 4ac for the discriminant part, and we've got negative 5 squared minus 4 times 2 times 4. So 25, and that's going to be minus 4 times 4 is 16, times 2 is 32, minus 32. That should be negative 7. Now, since that's less than 0, we expect no real zeros. In other words, they're all going to be imaginary. Okay, now let's do the quadratic formula. All right, so we got x equals negative 5 over 2 times 2 plus or minus the square root. We found that to be negative 7. And over 2 times 2. The only thing I expect you to do here is for the negative 7 inside, I'd like you to rewrite that as positive 7 and then times I afterwards. And that's it. I think that's it for this side. Let's look at the complex number side. First thing, and again, this is one where you have a chance to earn a bonus point. If you rewrote this as the the positive square root of 75 times I, you've got full credit. Woohoo! If you'd like to go further, this could be rewritten as the square root of 25 times the square root of 3i. Square root of 25 would be 5. Square root of 3, and then I. For number 7, we've got some combining of like terms. I'm going to do this one all horizontal just to break things up a little bit. So first thing I might do is to get rid of all my parentheses and just rewrite this as 2 plus 7i minus 11. I've got to distribute this negative. That's really why I'm doing this way. And that's plus 4i plus 3 plus 2i. Okay, we've got 2 minus 11, which is negative 9, plus 3, it's going to be negative 6. And we've got 7i plus 4i is 11i, plus 2i is 13i. So negative 6 plus 13i is our final answer. For number 8, we're going to do some distribution. That's going to give us 8i, and then plus, should be minus 12i squared. We know that I squared is negative 1. So that would be 8i minus 12 times negative 1, or 8i plus 12, which I'm going to write as 12 plus 8i. For number 10, we're going to do some distribution again. 3i times 3i is going to be 9i squared. 3i times minus 9 is going to be minus 27i. 9 times 3i is plus 27i, and 9 times negative 9 is minus 81. We know that I squared is negative 1, so 9i squared would be negative 9. The plus and minus 27 both cancel out. Then we're going to have minus 81. All told, this gets us negative 90. Next up, we've got to do some completing the square and some circles. So let's start with completing the square. Okay, always the first thing I want to do is try to figure out what this should be to be a perfect square. And the way I'm going to do that is take this b number, so that's 4, I'm going to divide it by 2, and I get 2. When I square that, I get a plus 4. That means that instead of 1, I'd like that to be a 4. I'm going to add 3 to both sides to make that happen. So y plus 3. Then we've got x squared plus 4x plus 4. Next we got a factor. The shortcut here is that this is going to be whatever this number was before you squared it. So 4 divided by 2 is 2. And on the side we still have y plus 3. That means that y is equal to x plus 2 in parentheses squared, and then minus 3. Then we got to graph this thing. Okay. This means my vertex is going to be at negative 2, negative 3. So there we go. Since we've got a coefficient of 1 out front, I'm going to go up 1 over 1 on both sides. I could also take a look at the y-intercept here. That's going to be right there. And my graph would be something that looks a lot like this. Not too bad. Definitely not the worst parabola I've drawn in this thing, but not the best. All right, for number 12, we're looking at the equation of a circle. First thing I do is identify the center. It's going to be whatever makes each parenthesis 0. So in this case, 5 and negative 1. And finally, we've got the radius. That's going to be r squared. So in this case, r squared is equal to 4. That means that the radius is going to be 2. So center at 5, negative 1 with a radius of 2. There's 5, negative 1. For the radius of 2, I'm going to go up 2, 2 to the left, 2 down, 2 over, just to give myself 4 points that I can see really well. I'm going to ask that you do that too. And then we have a reasonable looking circle to go through there. You're going to lose points if I can't clearly see that you tried to do a radius of 2. Like if one side has a radius of 7, the other side has a radius of 1, but you tell me it's supposed to be 2, you're not going to get full credit for that. Next up, we got some systems of equations. I'm going to go through 3 of these with you. First one, I take a look at this and I see that this looks like a really good elimination one for me, because this is already set up on top of each other, and that's much faster than trying to get one thing by itself. I'm going to deal with the, I'll get rid of the 7s, by the 7s being the y's, because I've already got a plus and a minus here, and either one would actually work for us. To do that, I've got to find basically a common denominator, except there's really a common coefficient. I'm going to multiply the bottom by 7 and the top by 3. We're going to try to make these 21 so that we can cancel them out. We get 9x minus 21y and minus 33. And then for the bottom one, we're going to have 14x plus 21y and plus 56. I like that I lost my equals in here. That's a really important thing. I cannot lose that. So then I'm going to add these equations together. This is a linear combination. And we're going to get 23x, 0, and negative 33 plus 56 is going to be 23. That means that x equals 1, and I've got to plug it in to find y. I'm going to probably use the second equation, although it doesn't really matter. Both these are ni. So we get 2 times 1 plus 3 times y, and that's going to be equal 8. If I minus 2 to both sides and divide by 3, I get y equals 2 in pretty short order. So my answer here would be x equals 1 and y equals 2. For number 14, this looks like a great substitution problem for me because I've already got a y by itself. That means I can plug it in for y in the other equation. So I'm going to make this, 5, and then instead of y, 3x minus 5 minus 15x and equals 3. All right, so we get 15x minus 25 minus 15x is equal to 3. Those cancel out. We get minus 25 is equal to 0. This is a false statement, and that means that we have no solution. The reason this happens is that these two lines are parallel. They will never intersect. For number 17, we've got a system of quadratic equations going on here, and I'm going to start off by setting them equal to each other. So it's going to be x squared is equal to 6x plus 7. And this is where I'm seeing some confusion about what to do next. The big idea here is I want to make this equal 0. I don't have any other way to solve things if this does not equal 0. So I'm going to minus 6x and minus 7 from both sides. And that's going to leave us with x squared minus 6x minus 7 is equal to 0. And by golly, this looks factorable. We got your a times c is negative 7, the b is negative 6. That's going to be negative 7 and positive 1. This is going to factor into x minus 7 and x plus 1, which equals 0. That means that x equals 7 and x equals negative 1 would be our two solutions. From here, we have to go back in and plug these in to find y. To me, that equation actually looks a little bit easier. So if I plug x in, that gives us y equals 7 squared, which is 49. So we get 7 comma 49 is a point that works. And if I plug in negative 1, we get y equals negative 1 squared, where y equals 1. Okay. And that gives me the point negative 1 comma positive 1 as a backup point. So we got two different points here that would act as intersections of the parabola on the bottom and the line on the top. Now we got some word problems. I'm going to go through the first one here. This should be way better off than the ones we had last week, which we had lots of no solutions things. So the first one, we've got Dr. Potter, who's providing vaccinations against polio and measles, saving the world one dose at a time. And each polio vaccine consists of a number of doses. Each measles vaccination consists of a number of doses. And we've got 60 vaccinations and 884 total doses. So some of the stuff we don't know. We don't know how many different things in terms of how many polio things, how many measles vaccines are given out. All we know is the total number of things. So to write some equations here, I might do an equation for total doses just because that's what my pen had first. And for that, it's going to be 184. And that's the doses polio plus, I'm going to write D measles and I know that the number of vaccines of polio, okay, that's going to be 4 times that. So I'm going to call this 4P for 4 polio, and I'm going to call this 2M for 2 measles. And that's going to be, P is the number of polio vaccinations, and M is the number of measles vaccinations. All right, I also need a total number of vaccinations. Cool. So that's 60 total, and that's going to be equal to the number of polio plus the number of measles. Okay. With the stuff that we have here, I think that elimination might be a pretty good idea. There's not a lot of room, so I'll try to make some sense of this. And I might try to multiply the bottom by -2 to cancel out the measles ones. So that'd be 184 is equal to 4P plus 2M, and -120, I'm doing times -2, is equal to -2P plus -2M. When I add those up, we get 64 is equal to 2P plus 0. That means that P is equal to 32. And based on that bottom equation, these things got to add up to 60. That means that M is going to be 28. So I'm going to ask you to write some kind of a final sentence or observation just saying that there were 32 polio vaccines and 28 measles vaccines. And last up, we got the new stuff. We've got exponent rules and some polynomial things. For number 22, I can see pretty clearly that we're multiplying some things. I might just try to multiply the numbers first. That would give me 6. X to the -4 plus -2 would be -6. Y to -3 plus 5 would be 2. I'd like to get rid of that negative exponent. One thing I could do would be to rewrite this as 6 times 1 over x to the positive 6 times y squared, or alternatively, and the way that I tend to write these is going to be 6y squared. Those are things with positive exponents, and x to the 6 in the bottom. These mean the same thing. They both will give you full credit. And there we go. Number 25, I'm going to start the same exact way. I'm going to look first at the numbers. Okay, 15 divided by 3 is 5. X to the -5 divided by x to the 3. Well, I know that dividing means subtraction of powers. -5 minus 3, that's going to be x to the -8. Same thing for y to the 4 divided by y to the 2. 4 minus 2 is going to be 2. In terms of getting rid of the -8 on the x, one way to do that would be to write this as 5 times 1 over x to the 8 times y squared. Another way to write this would be 5y squared over x to the 8th. All right, for number 26, we got a lot of stuff going on here. I'm going to try to make some sense of this. And I'm going to start by collecting terms that are the same. So you've got -12, that's a number. I'm going to do minus plus 11 and plus 3. So -12, there's my minus, positive 11, and then there's my plus, positive 3. In other words, -12 minus 11 is -23, plus 3 is going to be -20. All right, then we got x squareds. 6x squared minus 5x squared, nothing, and then plus 2x squared, and that's going to be 3x squared when you add those up. Next up, we got minus 10x to the fourth. So minus 10x to the fourth minus 8x to the fourth plus, and there's nothing else there. Okay? Minus 10 minus 8 is going to be minus 18x to the fourth. Nothing is left unlabeled, or at least it shouldn't be. That 2x squared should be underlined. So what I'm going to finally do is kind of combine these three pieces. Ideally, I'm going to write the x to the fourth first, but it doesn't actually matter. So we got 18x to the fourth. We're going to do plus 3x squared and minus 20. And for number 27, we got to do some distribution. 5x times negative 7x squared is negative 35. X to the third. 5x times 2x is going to be plus 10. X squared, and 5x times minus 3 is minus 15x. Then we got plus 1 times minus 7x squared, minus 7x squared. Plus 1 times 2x is going to be plus 2x, and plus 1 times minus 3 is going to be minus 3. When I then go and add these up, we get negative 35x to the third plus 3x squared minus 13x and minus 3. And that's it.